Prashantji, I'm just creating the YouTube live.
Yeah, sure. Go ahead.
You are now visible on the YouTube live, Prashantji.
Okay.
So I'll share the links also. Prashantji, I'm just creating the.
Good afternoon to all the educators. Macmillan Education has been in Indian education space for over 126 years, and our rich legacy is based on the strong relationships that we have built up with institutes, educators, and authors. We have always been at the forefront in supporting the education fraternity, and today's webinar is another such step. Please join me in welcoming our resource person, Mr. Syed Sattar. He is well known for coordinating and conducting teachers' workshops on realistic maths education for schools, NGOs, and government bodies. He has extended his skills to thousands of schools in development of maths curriculum and setting of maths lab for middle and senior level classes. He is the member of Curriculum Design and Research Unit and coordinates with various educational events for regional workshops. He was invited for a talk on realistic math education by Doordarshan channel. He also works as a consultant and Commonwealth Society, a regional education NGO of UP, and has been actively involved in various government educational initiatives like Sarv Shiksha Abhiyan. May I ask Mr. Syed Sattar to please take this webinar forward?
Sure, Prashantji, thank you very much. And
thank you.
After this little long introduction, let us go a little more realistic. And today's session is on realistic mathematics education. The session, it tells you, or sets the tone for today's interaction. Though before interaction, I would like to welcome you all on this, though it is not going to be very interactive because of certain reasons. But the thing is, the most important part is that technology is so efficient now that we all are meeting each other virtually. and talking realistically on the very real cause of mathematics education in our schools for children. And we all must agree to this point that we are here not for ourselves. You are not here for me. I'm not here for you. We all are here together for our learners who are there in our classrooms generally, but who are there at their homes, stuck with their parents, or I would say parents are stuck with them. So now, how to make mathematics learning, full of joy, even when they are at home and there are no regular school classes are, happening. But the thing is, at the same time, there will be some insights, some discussions on mathematics education in general, and what it takes to make this a successful transaction. When we talk about math learner, we always think about mathematics as an abstract subject. We can think about ourselves as a math learners when we started. All right, so through the chat box, you can interact if possible. If not possible, then though there are certain points that I would like to put before you before actually starting the slideshow. The thing is, like, there will be some questions from my side, and I would request you all, though you are, maybe I think in the comfort of your homes, but the thing is still, if you can make yourself a little more or little uncomfortable and work on those tasks and activities, and be with all of us and others who are doing and thinking about the cause of mathematics, or willing to share new insights into this area, which is always the area of concern amongst educators. So there will be some tasks, activities, and some sharing of the thoughts. Okay, so I want to share my screen. That is on today's session. It is a realistic math education. So the screen is there in front of you. And Prashant ji and Akarti ji, these both are there with me from Macmillan office. So in case there is any technical problem or issue or anything that you want to inform me about, so please do that promptly, so that I can just take care of that from here. Okay, so shall I put this on the slideshow? Okay, so this is the first slide that says realistic math education, creating climate of possibilities. I have this particular picture here, the climate of possibilities. The teachers who have seen mathematics at graduate level and maybe I think 12th level and beyond that. So the thing is, like, they might have seen such kind of examples where the calculus was being used in order to solve the problems related to waves and other things. And see, this is the wave of COVID that we all are experiencing, and let us see if we can do something with our mathematical knowledge. There are two kinds of research that are going on. One, the mathematicians who are working to tame the spread of the COVID these days, and there are some medical practitioners or medical scientists who are trying to come up with a vaccine for this disease. But the thing is, both are going parallelly, and the work of both the teams are of paramount importance. So mathematics is there, and which is guiding us throughout the problems, throughout the solutions, throughout the events, throughout the natural phenomenon. Okay, so we are creating the climate of possibilities. Let us see what kind of possibilities. When we talk about mathematics, what are the thoughts that come to your mind? So in the next slide, how do we look at mathematics? What are there? When we think of math, when this word is in front of us, what kind of visuals do we get in our brains? What kind of visuals do we get in front of our eyes? Sometimes we go back, those, we all are practitioners. And yeah, as I just advise or maybe request, my humble request, though you all are math teachers, but still, if you can manage a good smile on your faces, please do that. I am trying, on my face. All right, so you too, please, and and be with us. So the math, it it makes a few words, a few pictures, few visuals to come in front of us through, I think, from anywhere, from the books or from the blackboard or from the teacher's own lectures. And then we see, oh yes, that is mathematics. But the thing is, when we look at math like that, then definitely there are certain things that we are missing. In the next slide, when I say that why does math exist? Actually, math exists because math is the way of life. You know, math exists. That's why the world exists. And it's not a big statement. I'm really sorry for making such a big and bold statement about mathematics. But the thing is, like we try to say like mathematics, the world is mathematical, the buildings are mathematical, you know, the leaves, even the, you know, the ant which is moving is mathematical, the cycle is mathematical, you know, everything is mathematical. But we should not say like that. You know, the world is not mathematical actually, dear teachers. We as teachers, I think the engineers can do or can say that, or some other people can say that, the architects can say that. But the thing is, like, we as maths teachers, we should rather, instead of saying that the world is mathematical, we should say that math is very worldly. There is a change. There is a change in perception. Math should be, you know, seen as a worldly affair. You know, the way we do parties, the way we do, you know, competitions, drama, theater, such should be the enthusiasm. Similar should be the enthusiasm of doing mathematics. You know, this will not be possible when we say that mathematical world. No, the math is worldly. All right. So this is, you know, the kind of request I would say you, you know, as maths teachers, please carry this and convey this particular message in your classes through online or offline mode, whatever you are. And kudos to you who are taking online classes. I think these kind of insights will really help you to make your subject little more bearable, tolerable, at the same time less threatening, more appealing to the students who otherwise would not want any mathematics in the online classes. Anyways, in the next slide, let us discuss which one is more mathematical. Like, if I simply ask this, I think you just please reply through the messages, or reply through yourself. Which one is more mathematical? So there is this flower shape and there is this square shape. Let us see if Akriti can tell me that what kind of messages are coming, and which shape you know, are the teachers you know, telling is more mathematical. And in the meantime, I would just ask you to carefully watch when I show this. This is square. This is square, and it looks very mathematical. Yes, it looks very mathematical. I just want to see some chats, and flower. Please give them some time to respond. Okay, and flower. All right, square and flower both are mathematical. Okay, so which is more mathematical actually? So this was my question. Oh, the shape has gone out. Okay, this was the shape. All right, I'm giving it time. So if this is a square and it looks more mathematical, so dear teachers, let me show you one magic. I'm taking another square, and these two squares I'm putting overlapping, and then I'm doing some kind of movement, and see, don't you think that these two squares, they make a beautiful flower pattern, the pattern that I have shown? So the thing is, if the square is more mathematical, then flower is further mathematical. Actually, it is even more. It is even more because it is the combination of two squares. All right. The thing is, our attitude towards mathematics should be questioned, should be challenged. The thing is, like, we see the square and see it is mathematical, or the square is related to mathematics, but not the flower. It doesn't come as a very natural thing. But the thing is, In nature, everything tells you, suggests that this pattern is actually the amalgamation of different geometrical shapes, standard geometrical shapes. Every shape is mathematical in this world. Every shape is mathematical, but the standard geometrical shapes, those are known by the word like polygons and certain other things. Okay, so simple. Make the flower out of it, and you take 3 squares, you will have even more beautiful flower. All right, so which one is more mathematical? That depends on our attitude towards mathematics. All right, so the thing is, if our attitude towards mathematics is little more friendly, then I think we will see different things happening for us, for our learners, for the mathematics in general, and for the world where mathematics is so much required in order to solve the problems. And the current situation, the COVID, the mathematics is definitely telling this the problem solvers the way out. Next slide. I have captioned this. What is your sine theta? Actually, those teachers who are not, at good terms with trigonometry, they will see. Yes, my sine theta, and see, it is not SIN. Actually, I have written here SIGN, and I want to convey a certain message through this word. I'm playing with the spelling here. Sine theta. When you listen to this particular expression of trigonometry, I think you might wonder that most of the people in this world who have somehow got mathematics education, but not quality mathematics education, they start looking down. And when they start looking down because of mathematics, it is the depression that gets created. When that is the depression, that is the angle of depression. And our angle of depression is directly proportional to our hatred towards mathematics. All right, and that's why so line of vision should be in front. If we want to see mathematics right in front, helping us, and we taking help of mathematics, and we together doing something like our ability to look at the patterns, to decipher the patterns, to decipher the codes, and our ability to take to make mathematics work. And then these two things together will give us the enough amount of confidence to solve problems. Okay, so please try to reduce the angle of depression when you are talking about and thinking about mathematics. And at the same time, same goes with your learners also. And your learners, I think they will not be doing it automatically. The thing is, for us, we have to make certain kind of environment, the conducive environment for them, especially in the subject of mathematics. Coming to the next slide. Dear teachers, when I ask you, okay, there are 3 zones. Now everybody is so aware of the zones. So there are 3 zones: red zone, orange zone, and this green zone. Think about yourself as a learner. Where were you in your learning days, in your student days? I'm sorry, I'm saying learning days. Everybody's learning days are, every day is a learning day. When your student days, in your school days, where were you? In which zone? I'm helping you by reading it out to you. So math phobia, math stress, math enmity, math anxiety, math trauma. This is in the red zone. Then math shyness, math inefficiency, math inadequacy, math blockage, math complex. All right. This is in orange zone. And then the green zone, that is math mania, math craze, math liking, math curiosity, and math courage. I think everybody might. So I think now this is the time that you should start telling us about your zones when you choose for your student self, means your student avatar. And I think we have started getting the messages. I think so that is the thing. The thing is, what creates, let me tell you the whole trajectory. We start with the math craze or math liking, math curiosity. First of all, we have the math curiosity. We have like we see the teachers teaching mathematics, and then there are some shapes, some numbers. But the thing is, like, the way those things are presented, we start getting math blockage. We start getting the complex because we are not getting good marks in mathematics. Then we stop learning mathematics. Actually, what makes us stop learning mathematics? That is also a big question. We don't stop learning mathematics. Something makes us stop learning mathematics, and that causes math inadequacy. When there is inadequacy in mathematics, our foundations are not clear, they are not robust, then there is math inefficiency. And then in the mathematical circles, especially in the classroom, where I would say where students, the front benchers, they are there talking about mathematics, giving all kind of responses, giving all kind of replies and the answers and the solution of the problems of the questions to the teacher. There we feel math shyness. Oh, shall I say this or not? No, I should not say this. This then adds on, and then it accumulates, and the cumulative shyness, inefficiency, then it makes traumatic experiences. Every class becomes a traumatic experience. Then we are at home and we are anxious. We have this anxiety of performance, and then we start hatred. We start hating mathematics. We start hating. We can't see mathematics without taking stress. We can't listen. We can't hear the name of mathematics, this particular subject, without getting stressed. And then this adds on, and then it becomes math phobia. And you know, when the math phobia is there, then the math victim comes out. The math victim comes out, and the teachers label that person as, oh, he can't do mathematics. It's not gifted. Only gifted people can do mathematics. Actually, that is a sorry state. You know, I will tell you, there is a very clear connection between this thing, that in all over the world, actually 78% you know, students, they leave mathematics, you know, after their secondary studies. They leave mathematics. They don't want to do it. They don't want to pursue it. But what is that? What is that actually? Maybe I think you might ask this question. Okay, okay. In post-graduation, why did you take, or in graduation, why did you take economics, or why did you take history? Because I didn't want to take mathematics, because I didn't like mathematics. Like, the thing is, you're not doing justice with history as well, because you took history as just by chance, because you didn't want to take mathematics. So is that the situation that we want for our learners to happen? Actually not. So with your zones in your mind, let us see. I hate mathematics. Now think about it. Your student avatar, what would that person think? Why would you hate mathematics? Because of these concepts? Would you hate mathematics because of exponents? Because of algebra or HCF? Would you hate mathematics because of other things? Think about it. You know, when there is a math phobia, we hate everything related to mathematics. Let us see if this sends you some signals or suggests something. What does it suggest? And that is my favorite slide. I hate math because of this situation. That is there right in front of the on the slide. It is not HCF. It is not exponent. It is not algebra. It is actually the way it is presented. I hate math. I would hate mathematics. I hated mathematics, or I will hate mathematics because the way it is presented. Because the way it is presented, because the way it is perceived, the way the attitude towards mathematics of the teacher herself. You know, sometimes I have spoken with the teachers, and teachers themselves don't like mathematics. Though they are teaching mathematics, but they themselves don't like mathematics. Is that the situation? Is that the you know, one particular cause towards the hatred of mathematics? That could be because I don't like something doing. How can I present it in a beautiful way? Let us see what happens next. So there are two options, dear teachers, with you. So I have two options here: excess exercise, execution, extra class, My God, then exile. Oh, then exam, then exit. And what I mean by exit, do you know? Do you know the first suicide of this season has happened in Kota? The child who wanted to pursue engineering was doing something there, but before the results were out, he quit. Actually, it is the exile, this excess of exercise, then the execution of the tasks, then extra classes of the same kind. It is enough to send anybody in the exile. And then there is exam. How the learner can cope with such a pressure. And then there is second option. We can explore, we can experience, we can excitement, we can give excitement. Then with the exuberance of that excitement, with that kind of experiences and exposure, the child goes for the exam and expresses really well. And then she excels. So if second option, I think you might agree with me that second option is a better option, then how can we make this happen? Can we make this happen? What it takes to make that happen? Think about it, reflect, retrospect. What it takes, like how do we make mathematics full of excitement, full of joy? Why the child will like to do mathematics? And when? And if yes, then how? Are there some suggestions? See, you can come up with several points, and everybody knows that yes, these are the things, these are the ways, these are the things. But the thing is, like, sometimes we are not having enough guts, or sometimes the system doesn't allow us to experiment. But the thing is, like, we. At the end, the syllabus, the subject knowledge, nothing matters. What matters is how is the teacher? How is the teacher? Is the teacher is of that kind? There is a thin line between being a willing teacher and then being a closed-minded teacher. The willing teacher is always having a growth mindset. Let us see. These are the things that I have come up with you. And you can see that we can do math through stories. We can do math through games. We can do math through projects. We can do math through objects. We can do math through TLM. We can do math through art, through history, through activities, through context, and through puzzles. And I think you might be having your own points as well. But the thing is, like, let us discuss around these points. Let us discuss. Yes. Nothing to forget. Please don't forget this. Math through B and B. And what is that? Book and blackboard, or book and board. And the thing is, like, are we doing just with book? I'm not saying, please don't get me wrong. I'm not saying that math through board or through books is bad. Actually, using only board and book is not recommended. Actually, maths should be multifaceted. Maths should be multidimensional. Maths should not be direct. Maths should be indirect. Maths should not be deductive. Maths should be inductive. Maths should not be totally question-based or question-solving experience. Maths should be problem-solving experience. Maths should not be linear. Maths should be beautiful, beautiful pattern of curves, lines, parallel lines, intersections. All right. So dear teachers, let us see what happens next. So let us do mathematics through context. So I have a very interesting context, and for that I would like to take the help of Prashant ji, or maybe someone else. So I'm just looking at the chat. Okay, there's no an option. Otherwise, I would minimize this. So the thing is, I'm presenting, I'm putting a problem in front of you. So there is the person, and the census officer comes and knocks at the door and asks for the age or for the number of children. The person says, I have 3 children. And then the census officer asks, okay, what are the ages of those children? So he says, actually, I can't tell you directly or deductive way. I will make you work to get to know. And then the census officer also is a very, very, a challenge driven person. So he says, yes, please tell me. I would definitely work out. So says the person in the house, he says, I have 3 children, and if I multiply their ages, I get 72. And then the census officer was not very puzzled. He started doing his own calculations. Then he says that the information is not completed. So can you please tell me what are different ages? What are the ages of those children? Though the information he is saying is not complete, but I'm saying information is enough. Can you please tell me the ages of those children through the chat? 4, 6, and 7. Okay, 4, 6, and 7. All right. Some other teachers. Thank you. Okay, 24, 2 and 4. No, there are 3 children. Thank you, Sneh Malik ji, for your comment. Thank you, Shobha Soni ji. 4, 6, and 7. There are and 2 and 4. There are only this. Vivek Bhatia ji, actually, this is age of 3 children. So you have to work out. So I'm waiting for other teachers to tell me what can be the ages of those 3 children. 5, 7, and 8, 4, 2, 9, 5, 7, 9, 4, 3, 6. Thank you. Thank you. And there are some other responses that I'll get from the teachers, and then I will. Okay. Okay. 3, 4, and 6. All right. Archana Rawat ji and Vanaja Shiva Ramakrishna ji. Okay. So yes, in years. The ages are in years. All right. Okay. Let us see all the possible combinations. Yes, please work out. So their multiplication, the multiplication of the ages of all 3 children, it is 72. Okay. Yes, 72. So what can be the ages of those children? And then the census officer is saying, okay, the information is insufficient. But this much we can know, okay, what are the ages of the children? Okay, 24, 7, 9, and 12. Okay, 9, 8, and 1. I am not able to hear. Oh, Revant Rajan. Oh, I think you will need to actually check for that. 7, 9, and 12, 9, 8, and 1. And people are really playing very safe. All right. Thank you, Anjali Nagarji and Indeep Kaurji. Thank you, Vivek Bhatia ji. These are factors of 70. No, these are not factors of 24. Actually, 72. Yes, and 3 factors. 2, 4, and 9. Okay, Baswati ji. Thank you, ji, Bhattacharya ji. And any other? Let us see. Okay. Thank you, Jyoti ji. All right. All right. So some other teachers, so those who are working, let me tell you, the information was insufficient. And this was the context. The information that is the next piece of information that I'm giving you is that the sum of those ages is 14. The sum of the ages of those children is 14. What could be the ages now? Yes, their multiplication is 72 and their summation, their sum is 14. So can you please suggest what are the ages? Yeah, work out, work out. All right. Kriti ji, yes, Vikas Chandra ji, yes. And Ruchi Agarwal ji, and okay, Dilna Sujit ji, 266662. All right, that can be, but the thing is, yes, yes, 833, all right, 266833. I think both of them will give us 14. Oh my God. Thank you, Dhanya ji. Thank you, Dhanya ji. And Anand Kumar Jha ji is saying 1, 7, and 2. I think, no, Anand Kumar ji, you have to really look at it again. The thing is, what this suggests is like the multiplication is, okay, 3, 3, and 8. Thank you, Madhav Ahuja ji. So there are two possible answers. One is 3, 3, and 8, and 1, 6, 6, and 2. The thing is, after getting the house number as 14, the census officer again looked at it and asked, hey, still the information is incomplete. And then the head of the house told him that my eldest child has gone to school. My eldest child. So when the, sorry, Meenakshi ji, actually, thank you, Sana Mirza ji. It is 833. Yes. So eldest child, when there is eldest child, then definitely the ages will be 8, 3, and 3. So there are, two twins. All right. So, so this is the context, and through the context, we are doing mathematics. When we do mathematics through context, so let me tell you one thing surely, one thing for sure will happen. Meenakshi ji, you have to really think about it. 8, 4, and 1 are not the right ages, okay? Because it gives the sum as 13, and their multiplication also is not 72. For unique solution, information is incomplete. That's why. So thank you, Math Pathshala. Somebody is who is having this account, Math Pathshala. So that's why I have given this last information that the eldest child has gone to the school. So the thing is, when there is this particular information, this revelation, this eldest child, the eldest child is actually possible only in the combination of 3, 3, and 8, and not 6, 6, and 3. All right. So there the youngest child will be possible. So again, he's saying eldest child. So definitely it is 8, 3, and 3. Okay. Thank you very much. And so what? Yes. Thank you very much, Purvaji. Thank you, Purvaji, Dalviji. I think, yeah, everybody, Dalviji, you have to relook at this question, the solution that you have. So what are we doing, dear teachers? What we are doing, we are actually through the context, what are the concepts that we have done? If I ask you this question, what are the concepts that we have done? We have done, let me just, go through that. We have done multiples. Do we? Have we? No. We have done factors. All right. Then we have done, factors, factorization of 72. All right. And then finding out 3 factors only. There can be many factors, but then those 3 factors which are giving us 72 as their product, and then those 3 factors, then we have to look which give us sum as 14. So there was one word that will describe this whole experience was exploration. Whenever there are contexts, there are explorations. Wherever there are explorations, there is problem solving. Because you are solving a problem, you are simply not solving a question. So there is a big difference between problem solving and question solving. So dear teachers, please make your students solve the problems, not just the questions, because since ages we have been solving the questions only. We have been solving the questions only. Thank you very much, Meenakshi ji. The thing is, Ramanujan didn't want to solve those questions. That's why he became Ramanujan. Newton didn't want to solve those questions. That's why he became Newton. Because do you know that Newton was the first person to have given us the sum of first n natural numbers, because Newton was in his class and the teacher was, as usual, busy in some other grading work, and then she asked, and then thank you very much, Yogendra Singh ji. I think, yes, prime factorization you can use, but the thing is, like, this is not prime factorization. It is actually asking you, prompting you to do something else, to explore. the situation, the context. Okay, so the Newton was in the class, and the class teacher, because she wanted some time, some cool time for her grading work, she wanted some peace and calmness. So she asked the children, the students, please add all the numbers from 1 to 100. And she was expecting that the entire duration of the period will be consumed when they will work out this particular sum. But the Newton was the first person. Within 2 minutes, he stood up and he said, listen, ma'am, this is the sum. And it was 5,050. What happened? What happened? How could he do? Because he didn't want to solve the questions. He wanted to solve the problems. This was his own problem. This was the problem he didn't want to actually waste his time on. He wanted some nice way to visualize that. And then he could do that. Einstein, he said, please don't teach your learners. Instead, make learning environments. How will you make learning environments? By the textbooks and the boards. With that, is it possible? I'm really sorry. We have to make learning environment through the contexts which are mathematically rich. Thank you. Factors, arithmetic progression. Yes. RS Zindagi 26, I think. Thank you very much. It is arithmetic. Yes, there are, Newton gave that at that time. And he was not, I think he was in middle school only, and he was not doing arithmetic progression at all at that time. But the thing is, he could decipher. He could see the code. He could see the logic behind that. So this is the context. I think if you use contexts, dear teachers, you will see wonderful things happening in your classes. Now, mathematics through puzzles. As if like contextualization of mathematics or mathematization of context was not enough. So let us see. I have the puzzle for you. So dear teachers, now I will need more of your involvement and participation, especially for this particular puzzle. Can you please imagine you have the coins of ₹1, ₹3, and ₹5, and you have multiple coins. So I give you the challenge. You take 10 coins in all, 10 coins of ₹1, of ₹3, of ₹5 in any number, but total coins should be 10. Can you make 25? And yes, there are more than one ways of making 25. Please give it a try. And please share your opinions, your solutions, your questions, your queries, your maybe I think problems, your troubles with us through the messages, please. Yes, please try making 25 using 10 coins. And the coins are denominations 1, 3, and 5. Let us see. Yes, and Agarthi ji is so efficiently showing all the messages to me because otherwise it's not possible for me to see and look at your messages. So Agarthi ji is there. So you please keep populating the message box for Agarthi so that she can show it to me as well, and I can then proceed further. All right. And you have to tell me the number of coins, and you can use any kind of like algebra if you want to use, or any other logic that is there working at back of your mind. The thing is 10 coins you have to take, total 10 coins. So if you are thinking about X, Y, and Z, then total X plus Y plus Z should be equal to 10. So this is a puzzle, and let us see what kind of mathematics do we do with it. All right. And please, I would request you not to search the internet for that in order to get to the solution. The thing is, solving this problem will definitely open some new vistas in your perception of mathematics, especially the mathematical tools at middle school level and primary level as well. Okay. And just with I'm waiting as you are just working on that. I think it tells us that you are struggling, but I know there are some mathematical nerds who are working on it robustly. Let us see who comes first with the answer. Yes, let me remind you, please keep smiling. All right. So those who are trying this out and not getting through, so let me tell you, dear teachers, let me tell you one thing. I have something with me. I will share with you. I have something with me. So let me share it with you. And then this will give you the answer. Thank you for trying this out. Thank you for trying this out. Can you please tell me? Can you please tell me what number is this? 2. Is it even or is it odd? What number is it? Even or odd? It is definitely even number. Now I make this 3. It was 2. So now those who are trying, please stop that and look at this activity. So those who are doing that, just please look at it. So now it has become 3. Is it odd number or even number? This is odd number. So this is odd number and this was even number. So what I am going to tell you is not very trivial. Okay. Now, this is another number that I'm making. And I think you would agree with me that this is also an odd number because it is 2, 2, 4, and 1, 5. And this is 3. When I add 2 odd numbers, I will always get an even number. Do you see that? Does it actually light something? Does it give you any thought, any new thought? Definitely. You know, when you are adding odd numbers with odd numbers, you can't get an odd number. So odd plus odd will never be odd. And I am asking you to make 25. You can't make. You can't make. Using 10 coins. Means odd numbers adding together even number of times will always give you even number. All right. So that is the thing. You can't make 25. I'm really sorry. So the thing is, like, we keep teaching odd numbers and even numbers, but then we stop there. We as teachers should be very much aware of those intrinsic patterns, intrinsic logics behind these mathematical tools, which are very, very efficient tools to solve the problems that are there in the world. And this is just simple odd and even. But the thing is, we are stuck there. Because this simple thing we could not do ever in our life using the concrete material. If we are not doing something with the concrete material, then I think without that experience, things will not happen. The mathematics will not happen. We have to do mathematics, not just teach it. And listen, dear teachers, what happens, any training program or any teaching program, if you want to teach, yoga, what will you do in the class? Will you teach yoga through books? Or just imagine you're a music teacher in your school. How that teacher will teach her children music? Will she teach her children music through the books only? There will be a practice. She will first show how the music is composed or music is created. Then only she can expect her children to create music. Now we are not trying to create new mathematics in our classes. We are trying to just present the mathematics which is already created and presenting it without giving any chance for recreation. Thing is, like, in the absence of recreational mathematics, mathematics will die. Mathematical zeal will die. Mathematical enthusiasm will die. Mathematical abilities will die. And the mathematics learner will be lost. And you know, the learner will never want to go back to mathematics. And it doesn't happen because of math. It happens because of the way math is taught or presented. Next. Similar, but little different. So those who are teaching, middle school level, primary level, yes, those teachers are with us today. So can we, and those who are teaching 9th and 10th, then they can also try this out. 24 is 8 plus 8 plus 8. So I have used 8 3 times. The same digit I have used 3 times. I have used same digit 3 times and I have made 24. Can I make 24 again using any other digit 3 times? Can I make? Can you try? And listen, yes, let me make it very clear for you. It is not. It is not that you have to use addition only. You can use subtraction. You can use anything. The only limitation is that you have to use 3 digits, same digits. That's it. Let us see if there are some messages. Akriti will definitely tell me. And now it's another chance for you to think a little differently about your mathematics. Feel about it. You will get to know that mathematics will never be the same for you. And because of what? Because of the experience. The thing is, we have to always give experience to our children. We don't give them experience. We give them exams. We give them extra classes. We give them excess of syllabus. Then they exit. The thing is, whatever we are doing here, these are explorations. These add to the mathematical excitement. So making 24 differently using 3 same digits. And yes, let me tell you, unlike the last example in the puzzle, this riddle is very much possible. It is possible if you try. Let us see. And those who are there, can you please suggest? Again, I will repeat that you have to use 3 same digits. 3 same digits. Any operation. Any operation. Yes. Okay. Try. And those who are trying, that's cool. And those who are waiting, of course, this is possible. Look at it. It will change the whole perception of mathematics there. Isn't it so? I hope this will, introduce a cool avatar of mathematics to you. And we are playing with the numbers here. And those teaching middle school classes and teaching exponents and powers, I think they will they might be smiling looking at it. This very simple relationship between 3 3s and 2 2s, making it possible to make 24 3 different times. So riddles and puzzles, they make you think of mathematics a little differently than what it is in the textbooks. All right, the thing is, where these puzzles and riddles are, where do we get it from, these things from? They are not easily available. Or sometimes when they are available, they are not very appropriate to the classroom teaching or to these kind of tasks to be given to the students. We have to actually look at the concept, and we have to think what are interrelationships, because mathematics is all about patterns and relationships. So this is the relationship. What kind of relationship is there among these three threes? So thank you very much for trying that out and for your persistence. Let us see what happens next. It's one more. Now it should be easier. It should be easier for you. Can you please tell me the value of each of these shapes? And yes, this system is in equilibrium. It is balanced. And the value of the entire system is 48. Any answers? And when you are doing it, then definitely you will be doing some very sophisticated mathematics. But please don't be afraid. It's not threatening. Sophisticated mathematics doesn't mean like integration, calculus, trigonometry always. Sophisticated mathematics is the mathematics which is real, which is realistic. And this is the whole thing that we are talking about. So what is the value of these shapes? The square, the star, and the circle. So if you can see, I have the board, behind me. So can I write this? So actually, if this is 48 in between, and this is balanced, so definitely, dear teachers, this will be 24, and this will also be 24. Isn't it so? When these are two things that we can decode, then this 24 is further into two parts. This is 12 and this is 12. Now you can see this entire system is in equilibrium. So these four squares, or you can say rhombi. The thing is, these are squares, a little different orientation. So 4 squares, they are is equal to 24. Then 4 stars, they are is equal to 12. Then 4 circles, they are is equal to 12. Now, can you work it out? If you can, that's great. If you can't, please, you can. Try it out again. No, these are the exploratory tasks. These are the puzzles, riddles, which, and it is not just the finding out the values of these things. If the square can be considered as unknown, means x. If square can be considered as x, then definitely this will be 4x. If this star is considered as y, then this will be 4y. And here in this system, 4x will not be equal to 4y because this one circle is z. So 4x will be equal to 4y plus 3z. This is another equation that can come up. Many such equations will emerge out from this system. 4x plus 3y, plus 4y plus 3z will is equal to 48. And such kind of equations in three variables you can get. All right. So it is endless possibilities. That's why my first slide was saying that let's create the environment. Let's create the climate of possibilities. This is possibility. If it is possible, then definitely you will. If it is possible for you now to look at it and smile at it, then I think it will be possible in your classrooms also. Okay, map through projects. What kind of projects do we give? Listen, our idea of a project is like a project is given. Sometimes the project is not very different from the activities. Project actually, it should have something, some different kind of experiences in it. Then it becomes a project. Otherwise, it is simple activity. So how far does my bicycle travel? This project, if you can see, I think I can share one this thing with you. Yes, I can share one thing. I'm sharing another screen. What is the need of a project, and how do we actually do the projects? So this project was okay, how far does the bicycle travel? So this project was saying okay, the child is actually working on this thing. Okay, this is the bicycle, and how far will it travel? What things are required to find that out? How do we actually go about it? And what are the implications of this? What are the maybe I think some technicalities out there. So I'm just showing you some last moments of this video. The child was
90.
just seeing how far does the bicycle go in one round of its wheel. So the child started with
100.
with a point from there, and he's marked that point on the floor, and then the wheel rotated, and the next point, the same point, and that point could be taken as where we fit in that air pump. So the thing is, when that point comes again and touches the ground, though tangentially again, so that child again marks there. When it marks there, so there are 2 marks in between those 2 marks. Now this is the whole length that is needed to be known. So, and then the child is doing that, and this is called the project. There is no book around.
20 and 100. After 120, and this much is more, so we will add these 5 numbers will become 125. So
125 what?
1 centimeter.
All right.
So our
Now, dear teachers, this was just a glimpse of the project. That was the thing is like, okay, circumference. Yes, thank you very much, Anjali Nagaji. That was circumference, and Sadhanata Thangaji, front and back side balance. Okay, okay, and Vanajaji. All right. Okay, Prem Lataji. Hi, Prem Lataji. Okay, so the thing is, yes, circumference it was. Yes, and Vanajaji, it was not directly linked with the diameter. It was circumference. It totally depends upon the circumference. Yes, it is circumference. But the thing is, the child doesn't know too much about the circumference. The child is actually looking at it as a problem statement. How far does the bicycle go? When the child will know that, there will be an amalgamation of circle and its properties, the line, the straight line, and the measurement and the units of measurement. This is something which is very important, in the projects. So such kind of projects you can refer, to the students through online classes. And through online classes, let me tell you one thing very, very important. Through online classes, when you are teaching, so please don't teach during the class only. I think leave them with some task in hand, so that when they come for the next class, they are prepared. And that task should never be solve the questions. Please, they can be, but the thing is something related to their lives. Something like any object, finding any object with given mathematical properties. That kind of task could be given. All right, and middle school level, I think task could be given like, can you please find out the value of pi, and when the bicycles or any vehicle are there at home. Yes, they can do that. Thank you, Rashina ji and Arpit ji. The thing is, when we are teaching, it is real teaching. It is called realistic mathematics education, where the children or students or anybody or any learner is not feeling the burden of doing mathematics or compulsion of performance. No, it's not about performance. It is about trying out. It is about efforts. It is not about performance. I'm really sorry for saying that. Thing is, we are making our students so stressed, so depressed because of this performance anxiety. Anyways, lots of things are there. So I'm sharing the screen again. So how far does my bicycle travel? So this is math through projects. The next slide is math through objects. And I personally like this phase of my workshop when I will take a powerful shape. And Prashantji would know that what is that powerful shape. I think he is helping us, coordinating with us. So I'm just taking that shape in front of you. And, though I have used it many times, but the thing is, can you see this shape? I'm just stopping the sharing the window, and I will show my window in front of you. Can somebody, Akriti ji, can you please put me in the spotlight for some time? All right.
Akriti, can you please help us?
Yes, thank you. You are visible. Okay. So yes, so if putting in the spotlight, I think it makes it a little more easier for everybody to look at it, then that's why. Okay, dear teachers, so look at this shape. What is this shape? This is obviously it reminds you of the square shape, and obviously it is square shape. I think if I hold it like this, then it becomes rhombus. It becomes rhombus, I think. Does it? Actually not. I can do anything with that. So it's like what I used to do is just asking you, what is the area of this square? What is the area of the square? This side is X unit. This side is X unit. This side is also X unit. So when both sides are X unit, so what could be the area? So it should be X square, no doubt. All right, but okay. When I fold it into halves, I just halve it, fold it from the, midpoint. So thank you very much. It is rectangular, it is a square, it is a body, it's a body. Yes, it's a rectangular. So be very, yes, these teachers are very technically very correct. Thank you very much. This is not a square, it is a square shape. It's not a rectangle, it is a rectangular shape. All right. And I would leave you with a very interesting question after some time. But the thing is, when this, I fold it into, I halve it by just folding it through the midpoint. So how much is the area now? X square by 2. Thank you very much. X square by 2. I know what is happening in the back of mind. And those teachers who are actually working with the area and perimeter in primary grades, if this 10, then 100, and now it is 50. So actually it is X square and X square by 2. Vivek Bhatia ji, sir, give some time. Actually, yes, you can take time. Thank you, Bhatia ji. So this is X square. If I hold it like this, just for a better visibility. So now this side remains X, but this side is X by 2. So what can I say? When you have one side of a square, then its area gets halved. This. Now let's talk about perimeter. Thank you very much, Vibhuti ji. Thank you, Khan Bilal ji. Now, if this is X, what is the perimeter of this shape? Obviously, it should be. If you're right, it should be 4x. Yes, you are about to type it. It should be 4x. But when I fold it into halves, just I halve it, then what is the perimeter? X by 2, X by 2. What is that? 3x. The thing is, halving this shape can halve its area, but not its perimeter. All right. So it means that halving it is directly proportional to halving the area. Directly proportional to the area. This fold, but it is not directly proportional to the perimeter. Okay. Now, but this, I am halving only one side. Now I have it's both the sides. This side already I have halved here like this, and then this side also I will fold it again through its midpoint. Now this becomes another shorter shape. Thank you, Geeta Pandey ji. Yes, that was 4x earlier, but now, and Ishita Chatterjee ji, it is not 2x, it was 3x, the perimeter. Now I am talking about the area. When I halve it both the sides, then the area is actually 1/4 of the original shape. And perimeter, x by 2, x by 2, x by 2, x by 2. Perimeter is 2x. So means like I am actually taking this, taking the quarter of the original shape, and I'm getting quarter of the area. But I'm taking quarter of the original shape, but I am taking half of the original perimeter. Isn't it very, very sophisticated, effective, efficient example of ratio and proportions? So you can use this shape. It is a powerful shape, don't you know? Okay, and thank you. Yes, thank you, Jins Renaud ji. Thanks a lot for replying. All right, now one more thing. Dear teachers, if this is x and this also x, I am folding 3 units from this side. So means I am actually reducing this side. I'm decreasing this side by 3 units. What will be the area? Earlier it was x square. Now what will be the area? Anybody? I know you will come up with the answers. And you know what happens when I fold 3 units from this side, and I'm saying units and only 3. This side originally was x. Now it is x minus 3 only. And this side is already x. So when x minus 3 and x, so what should be the area? And as somebody said, okay, give some time. So I'm giving some time. Thank you. And thank you, Shweta Rana ji, Maz Ali ji, Mukesh ji, Deepa Sahu ji, Ruby ji, for interacting with us. Though it is not very easy to interact, because there is in between there is interface, but still. So x minus 3 into x, obviously x square minus 3x. Thank you very much, Rajneesh ji. I think Rajneesh Tiwari ji has come up. X and x minus 3, and I'm asking about the area. And when I ask about the perimeter, then it will be x and x, 2x, x minus 3, 2x minus 6. So total perimeter will be 4x minus 6. Okay, sir, there is some time lag. Oh, okay, Rajneesh ji. I understood. So I'll be a little, slower now. So what is the point? The whole point is, through taking this simple object, we are taking, just using this to give or to make or to create a very good amount of mathematics. The algebraic reasoning, the algebraic, manipulations we are doing here. And I folded 3 units from this side. And now it will be further amazing for you if I fold 2 units from this side as well. Thank you, Minakshi Bhatt. Thank you, Amandeep ji. Thank you, Ikna Yasha ji. Thank you, Fatima Ansari ji. Thank you very much. Perimeter was 4x minus 3. Actually, it was, yes, thank you. 4x minus 6, as per my understanding. Thank you, Dania ji. Okay, thank you, Kartikeya ji. Now, from this side, 3 units I am folding, and this side, 2 units I am folding. Now this side remains x minus 3, and this side remains x minus 2. So x minus 3 into x minus 2, and you will get the expression for area. And what will that expression, Vanaja ji? That expression will be quadratic expression. Everybody, please write down that expression for the area when this side is x minus 3 and x minus 2, another side. I'm waiting. Thank you, Prashant Lalji. How that side is x minus 3? Okay, Ishita ji, actually, because this side originally was x, I just folded 3 units from it. Thank you, Deepti ji. Thank you. So, okay, x minus 3 and x minus 2. Thank you, Priyanka Mendirata ji. The thing is, what I want, I need the standard expression, the standard quadratic expression. X square minus 6x plus 6. Actually, it should be x square minus 7x. Thank you, Ashok ji. Pawan Bhardwaj ji, hi. Ashok ji, it should be x square minus 7x plus 6. Okay, so that is the, so from this one single piece of paper, what different things we are doing. We are doing ratio proportions. We are doing linear equations, expressions. We are doing quadratic expressions. We can do even cubic expressions also. Let me show you. This is a cuboidal thing. And when I keep this cuboid somewhere, can you please find out its volume? As I told you, this side is, I have folded from here 3 and from here 3. So this side is x minus 6. This side is 3. This is also 3. Height is 3. And this is x minus 6. And this was already x. Listen, you will get expression for the cube, the cubic expression with just one paper. And those teaching polynomials of different degrees, it depends. It makes it very, very effective, a way to communicate this whole idea. Thank you, Santiji. Thank you. Very effective way to communicate this idea to your learners. Okay, and this is just one piece of paper. And in primary grades, dear teachers, in primary grades, you can do fractions. 1/2, half, 1/4, 2/4, 3/4, 4/4. When there are 4/4, it becomes 1 whole. When there are 4/4, it becomes 1 whole. Okay, now this is 1/4. Thank you, Yogendra ji. Now this 3, Yogendra ji, like 3 dimension. Yes, thank you very much, Pawan Bhardwaj ji. Yogesh ji, which I am saying, this 3, we can still make it in terms of x, and that will make it 3 degree. So I was telling primary teachers, so if this is 1/4, I further halve it. I further halve this 1/4. Do you know what you will get? You will get 1/8. You will get 1/8. So that's why 1/4 into 1 into half is always 1/8. Okay, this is the multiplication, isn't it so? And so nicely. All right. And when you open this, then how many 1/8 will be there? There will be how many 1/8? 1, 2, 3, 4, 5, 6, 7, 8. 8 1/8 will be there. So the thing is, when you divide any whole by 1/8, you divide any whole by 1/8. Thank you, Harshita ji. When you divide one whole by 1/8, you will get 8. This is the division of fractions. So just with one piece of paper, you can do wonderful things. And I'm not going into further details of it because I have some other things to do. So I'm sharing my screen with you. I hope you liked this, doing mathematics through objects without any burden. How have you liked it? Please tell me through the chat box. Thank you very much, Mazali. 16. Yes. Now, I further divide this. It is 1/8. And now divide it into further half. So it will become 1/16. 1/16. This will be 1/16 of the original. Thank you, Mazali. All right. Hello, sir. Soumya Jaiswal. Hi. So I'm sharing my screen now, and let us see what is there for you. Okay, just a minute. Okay, so this was a powerful shape. That was powerful shape, and that was square or rectangle shape that you can use. And based on the rectangle only, this Singapore has developed that bar modeling. So whatever I was discussing with you, it was very related to bar modeling. Okay, now on the next. Oh, really? Math through TLM. That I have done already. But the thing is, I will do just in front of you the number of prime importance and the number closer to 2.0. So it reminds me of one activity. Can you please, dear teachers, think about, especially primary teachers, how do you teach primary numbers? And those teaching in 6th grade also, they teach prime numbers and prime factorization. So how do we teach prime numbers? How do we think about prime numbers? So is there any way? So I will just give you some glimpses. How can we do that? I'll stop sharing for some time, and I'll show you something with that. So dear teachers, this activity I have been doing for last many years, but I will just share with you again, and I hope you will like it. So this activity is just like that. So if I have two, if I have these two blocks with me, look at the surface of these two blocks. What kind of surface would you get? Just look at one surface. Again, it is very related to the powerful shape that I was discussing with you, but the thing is, it is math using TLM. Okay, this is specifically mathematical TLM, all right? So what is this surface? What shape does it look like? And I'm not asking about these circles. I'm asking about this whole surface, this face. This is a cuboidal shape, but it's one face, this face from one side. Its side view is rectangular. So this is rectangle. And how many rectangles are possible? So I'll just go through it a little in a speedy way. And this will give you an idea of dealing with these kind of numbers. So the thing is, like when I say that this is a rectangular shape, so can we think of making another rectangle using these two blocks? This can be another rectangle. But if this is a rectangle and this way is another rectangle, so this way will also be another rectangle. This way will also be another rectangle. The thing is, like, there are infinite many rectangles like that, but technically this one rectangle is unique. The thing is, with these two blocks, I can just make only one rectangle. Okay, thank you. Now, if I have 3 blocks, then how many rectangles are possible? Think about it. Not more than one. Where I have 4 rectangles, or 4 blocks, and I'm joining and I'm saying we have to take all the blocks together. When I have 4 blocks like this, then how many rectangles are possible? So there are two kind of teachers, two kind of opinions teachers have. They say only one rectangle is possible. Some others say no, there are 2 rectangles possible with 4 blocks, and second rectangle also I will show you. And this is the second rectangle which they actually tell. One is this one and one is this one. The thing is, both of them are using 4 blocks. But this looks like a rectangle. This doesn't look like a rectangle. Does this look like a rectangle? And let me tell you, dear teachers, this is another rectangle. This is one rectangle. Square is also a rectangle. And I'm waiting for such kind of messages from your side. The square is also a rectangle. So there, with 4 blocks, there are 2 rectangles possible. All right. Now, what about 5? If I have 5 blocks, only one rectangle is possible with 5. No any other rectangle. What about 6? Now it will be, I think we can speed it up. With 6 blocks, yes, more than one rectangle are possible. With 7, only one. With 8, more than one. With 9, with 9, more than one, I think so. Yes, those who are thinking only once, please think again. 3, 3, 3. That's square. Okay, with 9 there are 2, and then with 10 there is only 1. No, there are 2. Then 11, yes, again 1. And dear teachers, when the rectangles are only 1, those numbers are called prime numbers. So easy. We can always make a table. We can make a table on the board, and then we can say, okay, yes, the rectangles or the numbers which give us only one rectangle. So I am just showing you here. So this way we can do in our classes. So we can see, we can say that this is the table. Here only one rectangle, and here more than one rectangle. So the numbers where only one rectangle is possible: 2, 3, 5, 7, not 9, 11, and so on. These are prime numbers. Others are composite numbers. I'm not writing those composite numbers. But the thing is, please don't think like prime numbers are only of prime importance. They are of prime importance because of certain properties that they possess, and because of these properties, they are used extensively in army communications. and you know, when you go in 9th and 10th grades, then first fundamental theorem of mathematics is based on that, and they are responsible to give you HCF in the most you know, convenient way. All right, so that was the thing. So let me show you the slide again. That was mathematics using the, yeah, one more thing before I share the slide. One more thing, mathematics using TLM. So this is another TLM that I am you know, holding in front of you. You can use the straws that you use to drink beverages. Those straws you can use, and the board pins, you can join them. I'm using some metal pins here, and you know, these are very flexible, so I have this material with me. But the thing is, I have come up with this triangle. I will show you the power of TLM. This triangle, if I have this triangle and I want to change its position, I think its position can't be changed. I can't change this angle. I can't change this angle. This will remain sturdy, robust. But if I have this square or rectangle, and I want to change it, I think I can change. Oh my God, this is changed. Now it looks like a parallelogram. It looks like a parallel. I can change its shape many times. It looks like a very different parallelogram. Because its angle I can't fix. But in triangle, in the case of triangle, the angles were fixed. Why? The whole idea is, I'm actually showing this thing to you is that please give such experiences to your students in the classes. Or when you are next planning the online class, just ask them to sit with the straws and the pins. And then tell this very beautiful concept of congruency. When there are three sides, you will have unique shape of triangle, unique shape. Wherever, in Paris, in London, in America, in South Africa, wherever, Finland, wherever you draw a triangle using those three sides measurement, everywhere the triangle will be same. But if I give you four measurement, you can draw a square, you can draw this wala parallelogram, you can draw this parallelogram, you can draw infinitely different quadrilaterals with four measurements. The thing is, like, for this side is not a congruency criterion for the quadrilaterals, but it is a criteria. Side is a congruence criteria for the triangle. That's why we do one thing. That's why always any polygon, if we want to study that, we have to break that into triangles. See, if I break this polygon into triangle, this quadrilateral into two triangles, now it is fixed. That's why we study the congruence of triangles only. Because once we are sorted, thank you, all sides are adjacent to either. No, yes, thank you very much. Kalpana ji, actually it was not fixed. Thank you. A rectangle, yes, equal and a full form of TLM. Teaching learning material, Sanjeev Arora ji. Teaching learning material, and yes, it is very interesting point that you know, a triangle is the strongest polygon. All sides are adjacent to each other. Actually, in a square also, all the sides are adjacent to each other. But the thing is, like they are. There is a little more to that, and that is something I am discussing with you. And yes, in triangle, all the sides are adjacent to each other, but that doesn't make it congruent. What makes it congruent is its own thing. Yes, thank you very much, Dhanya ji. Requires 5 measures to get a unique quadrilateral, and 5 measures because we want the congruency using the triangles. Okay, so this is something which can be done using the teaching learning material, and without that, such kind of congruency and similarity and these concepts will remain abstract concepts, because students, they are happy with the triangle but not happy with the congruence of triangles. They are happy with the polygons but not happy with the congruence of polygons and their stability. Why would I learn this? Why should I learn this? So that is the thing. Thank you very much. So I'm sharing my screen again, and this time it's just Okay, number closer to 2.0. All right, that I will do later on. So let us see what is next. Math through art. Okay, so that is very much related to what we just did with the triangle. See, this is art. Actually, if you Google that mathematics in art and art in mathematics, so what is more relevant, art in mathematics or mathematics in art? So the thing is like nothing like that, but mathematics through art or art through mathematics. All the Rangoli patterns, they are so mathematical patterns. All right, and beautiful at the same time. The patterns on sunflower, the pattern on cactus, and some other these kind of things. The pattern, these patterns are mathematical patterns. They give you mathematical insight. And the pineapple has very interesting patterns. You will see the prime numbers and Fibonacci sequence on prime on this thing. So I have given you this art piece in front of you. Do you see what is happening here? What kind of things are there? See, this is very angular drawing, and prominent shape here is triangle shape, and then second is circle, and you will see a very interesting scheme of things touching each other tangentially, and that's very important for a circle. All right, and there are some messages. I can't see that. Okay, math through stories, I will go. Okay, and okay, let me check the chat. I don't know, I can't see the chat actually. I can't see the chat actually. It's not opening here. Okay, so this math through, so there you will see the scheme of, and in the middle art, this middle drawing of the lady, the lower triangle, which is it looks like her skirt. So on that triangle you will see the scheme of similar triangles, the scheme of basic proportionality theorem. All right, and dear teachers, those primary teachers, you can see the students will be able to guess, okay, which things are there, which triangles are close to each other, and which are similar to each other, and these other things. Yes, please. All right, and then okay, some other things we can discuss. Listen, the very important thing is the angles, the angular shapes, the angular movements, and they will tell you all the specific angles, acute, obtuse. Are there some right angles as well? Think about it. Look at the third shape in her legs. Yes. And is there any right angle triangle? All the triangles are acute triangles. All right. Is there any possibility of getting an obtuse triangle? That is something that you can discuss with. So the thing is, with one art piece in front of your class, and you can discuss n number of things and make the whole environment mathematically rich, or artistically rich. That depends on you. Mathematics is mathematics. Make mathematics artistically rich. Artist though is already mathematically rich. All right, so these things are there. Now, next thing is math through stories. So context is one thing, and story is different thing. Through stories, you can ask questions, and the students will be there. So I really like this story, and I think you might be feeling this very tempting image that I'm sharing with you. So listen. There is this family, and where is child, there are two brothers, and this family and the mother makes the laddus for those children, and she says that everybody, the elders, will get 2 laddus every day, and younger ones will get 1 laddu every day, and then she makes the total amount of laddus required for a whole month, and she keeps in a jar, and then she keeps it there. But the younger one, given for his craze for the laddus, he starts eating without telling his mother, and then the mother gets to know, and there were all kind of dramas and everything that you can yourself just come up with through the story. But what kind of mathematics can we discuss with it? You can discuss like what is the total amount of laddus required for one whole month? What is the amount of laddus required for 1 week? If the radius of one laddu is 5 centimeter and the radius of the jar is the radius of the jar is 15 centimeter, then how many laddus can be fitted there at the bottom of the jar? All right, how many laddus can be kept around one laddu, where all the laddus are touching each other, and the central laddu as well? How many laddus will be there in a heap of laddus where they are put pyramidically? So much amount of mathematics and interesting mathematics you can discuss through the stories. I'm so happy, not just mensuration, but other things also, numbers and then algebra. Like if the elders are X in the house and the younger ones are Y in number, then what is the total amount of laddu in terms of X and Y that is needed for the whole month? So expressing, anything is possible when mathematics is done through different things, through stories. A story, in the story you can do any kind of experimentation, any kind of exploration, and then mathematics is mathematics. It will not get diluted. The fear of mathematics will get diluted. It will dissolve. Mathematics will never dissolve. So don't be afraid of taking risks, trying out new things, exploring new vistas in mathematics education. Yes, mathematical games are there. Have you ever played Ludo? I think you have seen cricket. Yes, cricket, full of mathematics. Know any game you can understand without mathematics. And one game that is called a very mathematical game is chess, but there you don't do any direct mathematics, and it is called so mathematical, but it's logical, isn't it? So have you played Ludo ever? Yes, then you might have seen a Ludo board, you might have seen those dice and everything. Yes, and so I will show you. So I need 2 volunteers and for this activity. Let me just stop sharing and okay. Okay, thank you. Oh, 90 laddu, and there are so many answers. Thank you very much. Worley art, arc line segment ray, different 2D shapes. Thank you, many more related to geometry. Thank you very much, symmetry, laddus, and okay. Thank you very much for your answers. So Prashant ji, can you hear me? And I want 2 volunteers from my team only.
Yes, sir, I can hear you, sir.
Okay, thank you, Prashant ji. Can we do some interesting thing for our listeners?
Sure, sir.
Yeah. So Prashant ji, I need Akarti as Akarti. I think is very busy. Can I have Ravi ji? Ravi ji.
Sir, I'm available. Please tell me.
Okay. Akarti ji and Prashant ji, you please both draw a line on a piece of paper. Just draw a line and write the numbers 0 to 20 or 0 to 10. I think just getting it short. And my listeners, please, watch this carefully. Let me show you. I have these 2 dice. These 2 dice, one is blue and another is red. So red dice will give us the negative number and the blue dice will give me positive number. All right. When I roll both the dice together, so the number on this one will be the first number, that is negative number. In between, there is a sign of plus, and then there is positive number. So for example, in the first throw, if I get 2 on this dice and 6 on this dice, so the answer will be -2 plus 6, and that is 4. All right. So Prashant ji and Akriti ji, you both are at 0. All right.
Yes.
Okay. So now for Prashant sir, I am throwing these two. I am rolling the dice, and Prashantji, I will tell you what is your score. And I am rolling the dice, and this says -3 + 4. Prashantji, where will you go? Yes, you have to move -3 + 4. So you have to move, and I think our audience, somebody from the audience can tell us very, rightly that it will be 1. I think everybody is clear with this. So Prashantji, you are at 1 now. All right.
Yes, sir.
Okay. Now, Akriti ji, for you, I am throwing the dice, and you have got -1 + 5.
4.
4.
So Akriti ji, you are at 4. Prashant ji, you are at 1. Akriti ji, you are at 4. And I am throwing the dice again. And this time, Prashant ji, -1 + 5.
4.
Thank you very much. Go 4 more steps ahead. And out of you two, whoever crosses 10 first will be the winner. Now, Akriti. These are the numbers. -1 + 3.
So 4 + 2, 6.
No, yes, 2 more. Thank you. Prashant ji,
Yes.
this is the time to retreat. -2 + 1.
-1.
Thank you. Akriti ji,
Yes, sir.
what is this? -4 + 5.
So 1 step ahead, 7.
Yes. Whenever you reach 10, please tell me and tell everybody. Now, Prashant ji, -2 + 4.
+2.
Yes. What is your number now, Prashant ji? What is your number now, Prashant ji?
6.
6. Okay. Okay, Akriti ji. Akriti, you have -4 + 4.
Stay there. At 7.
No, it is 7 only. Yeah, it is 0.
At 7, yeah.
Okay. Prashant ji, you got the jackpot now. -4 + 1.
-3.
Okay, so please move ahead. No, move back. Okay. I think, Akriti, you are going to win this game. Let us see. Akriti, can you make out what is this?
-4 + 5. So I just move ahead 1 space.
Yes. Oh, yes. Very sure. Keep moving. Prashant ji.
-4 + 5.
Yes.
+1.
Good for you. And Akriti, this is
3 steps back.
yes. And where are you now?
So I was at 8. I'll go to 5.
Why? -2 + 5.
-4 + okay, I'm going 3 steps ahead.
Yes, please.
I'm going ahead. So I've crossed 10. No, I was at 8.
Wow. So you are at 11.
Yeah.
You have crossed 10. So Akriti, I think you are the winner of this round, and claps from my side and clap from everybody, whoever are watching us, and and you deserve a chocolate. Okay.
For your throw of dice.
Yes. So Akriti, so you deserve a chocolate. When you are going back home, please buy one for yourself. Oh, you are already at home. So now I'll share the screen again. So this is, dear teachers, this was the whole thing that I wanted, that how can we do mathematics through games? And it is not just integers. It can be even numbers, it can be odd numbers. Like I can throw these 2 dice and I can say, whatever number comes up, you have to multiply that, and you have to move ahead whatever as per the number at the unit place in the product. So that also you can do. So endless possibility. That's why the whole idea in the first slide, on the first slide, I took it and I wrote there, climate of possibilities we have to make. Climate of possibilities. All right. Now next. So through games, you please create games, or You know, this is the most advanced feature of mathematics education is gamification of mathematics, gamify math. So games are the way out if in order to reduce the mathematical tension or the tension of mathematical performance, you have to really resort to the games. All right, now next. Math through activities. All right, I will just give you a glimpse of that, and then I will move ahead. So the thing is, like, this is a very friendly a thing, and it makes our work so easier, but it makes the teaching also so easier. You just show this screen in front of the class, especially when you are taking online classes, and you say, get these 1, 2, and 0. These keys are not available. Can you still make 100? You can use any operation, any number which are available. Any number of operations. So can they make 100? They can. So if they can make 100 if they say 5 into 5 into 4. They can make 100 like that. Any other thing? Any other way? I think through the message you can you can just tell me that what are those ways that those things can be made. All right, and then these keys are not supposed to be used, and then you can limit. Okay, you have to exactly use 2 operations, and both the operations should be different. And can you make 0? 0 is not available, 1 is not available, 2 is not available. All the operations are available, all other digits are available. The thing is, can they make 0 using exactly 2 operations? Can you please tell me? Anybody, those who are listening us today? Anyone? Can you make 0? And it is very interesting and challenging. You know, make mathematics teaching challenging, not burdenful. All right? Don't burden them. Give them challenges. Give them, let them have the craze of doing mathematics. Such kind of simple tools, they will actually prompt them to do mathematics, not just in classroom, but even after that. It is learning is not always the a function of teaching. Learning can happen anytime. When you are thinking about something, learning is happening. And after this experience, I am sure, I bet that the learners, your students, will be thinking about the calculators. And then you limit them, you can use only prime numbers. All other digits are not available. Can you make, using prime number only, and using 2 operations, can you make 100? And let us see if they can. Can you make any other number, not just 100, 1000 as well? 0, 1, can you make 1? And can you make -5 as well? Let us see if it is possible. Okay. So math through activities. Another activity that I am suggesting through this window is like English alphabet. There are some teachers who might be using this, but the thing is, like, in English alphabet, especially the capital letters, they are so rich. And their characteristics are so mathematical that you can use them so conveniently in your classroom teaching mathematics. This H, for example, I can ask that what are the things, what are the mathematical things in this H? What are the features? There are parallel lines. There are vertical lines, intersecting lines. There are right angles. There are angles. There is a transversal. And yes, isn't it so mathematical? I'm not saying, isn't it so artistic? And this art, this particular this particular view, this particular maybe what can I say, just the picture or the image or the drawing, if it triggers that kind of mathematics in your mind or in the mind of your learner, then I think things are sorted. Things are sorted. Then the child is going to be a math buff, a math nerd. And that is important. That's important in the given time. When that's important in the given scenario. When we in 2016, I think we were at 72nd rank in the list of 74 countries who participated in PISA, where ASER report is saying that the middle school graders who can only between 30 and 40%, only between 30 and 40%, these students can solve a division sum from class 4. Middle school level students, they can do a sum of class 4 level, only 32%, 40%. My God, something is not right. Something has to be corrected. And obviously, this shape is my personal favorite, and I am just leaving you with this thought that please use this shape, and you can use this shape to do to understand fractions, area, perimeter, different theorems of geometry, especially the theorems related to parallel lines, and the shapes between two parallels and on the same base. And then this relates to arithmetic progression, geometric progression. This relates to area, ratio and proportion. This can give you the sequences, the series, and the infinite series, where the Ramanujan was the master. And in the last, I used to play this activity. This activity is mathematics through activities, if we can do so. Activities can be of any kind. So this is my one activity that I wanted to share with you, but I think because of this the blockage and there is no direct interface between you and me, so that's why I could not play this activity with you. So this activity is Antakshari, and there we will not be singing the songs. We'll be telling the mathematical terms starting with a letter, with a particular letter, like with P. Can I say some mathematical word using P? So P could be something like the prophet, and then with T, somebody will say okay, T, tangent, and then with T again, triangle, and then E, so E for what, ellipse or something, and this way we keep doing the activity. And there are many other activities. This was just one representative activity out of that. So I am not finding it very. I'm not actually. It is very tempting. I wanted to do this with you and to interact with you, but somehow the platform, the technology, we have to then honor the rules of the technology and the limitations they are there. But I hope you are listening and getting the ideas. And the torture ends here. And with this note that personally, I am always ready to learn, though I do not always like being taught. And my name is Syed F. Sattar, and I like talking about mathematics. And I am most happy among the company of math educators and anybody who fears math or loves math or likes math. But I'm not very happy with the people who hate math without any reason. And when I say torture ends here, it is not the torture of the session or the torture that is happening because of COVID. Actually, torture which is somewhere in some class, online or offline, which is happening, and because of that torture, if some learner is leaving mathematics or developing math phobia, so that ends here, I am very sure. Thank you very much. I'm stopping screen share. Coming on.
Sir, thank you so much for your valuable session. You have played an instrumental part in supporting us on the journey, and today we take this opportunity to thank you for this wonderful session. Respected educators, thank you for attending the webinar. I'm sure that you must have found the webinar informative and worthwhile. Our primary goal was to increase our understanding for making math session more interesting and to provide resources that will support us in setting up a virtual classroom environment. I wish you the best in the upcoming school year. Thank you.